All right, I'm going to go ahead and get started because we've got a lot to cover today. So let's look in Buzz. I'm going to show this first on what we are looking at for this week. So looking at Buzz, Algebra 3. If we go to our grade screen, okay, we see Algebra review is due this week. Algebra, it's lesson 1, Algebra review. And also lesson 2, revisiting functions. Those are both due this Sunday. So we're going to hit both of those in our review this morning about what we're looking at. So let me switch to my other camera and let's get started on that. So what lesson 1 is going to be covering is looking back at Algebra 2 primarily. And Algebra 1, what things do you need to remember from algebra? Since you had geometry last, it's time to get back into the algebra side. So the first most important thing you can read that. PEMDAS. That's a D. Who remembers what that stands for? What does that tell us when we say PEMDAS? Somebody tell me what I'm referring to. Some people say, please excuse my dear Aunt Sally, but that's not necessarily what I'm talking about. Algebraically, what are we talking about? Order of operations. Thank you, Cody. That is absolutely correct. We're talking about the order of operations. Parentheses, exponents, multiply, divide, add, subtract. That is the order in which we do something when we have to solve an equation. We have to solve it in the correct order. We'll get the wrong answer. And of course, solving equations, that's a big part of what algebra is. So if we have like one-step equations, negative 5x equals 15. That's like one of the simplest things to solve, right? What do we need to do with that? Anytime we're solving, we're trying to get a variable by itself. We want to get the x by itself. So since we have a negative 5 times x, we need to divide both sides by negative 5. All right. So x equals negative 3 in this case. I'm going back to the very basics of algebra here, guys. We're reviewing, getting our math brain back in. If we had x divided by 6 equals 8, what do we need to do with that? How do we solve for x? Let's get our math brains out of storage that we had in for the summer. X divided by 6 equals 8. This is going to be a long class, it feels like. What are we doing with this?
Times both sides by 6.
Very good. Thank you. So we're going to take x divided by 6 and multiply by 6, just leaves us an x. And of course, x equals 48. So, all right, that's one-step equation. We're getting to two-step equations, which is like 4x minus 9 equals 15. So in this case, if we have something that doesn't have an x, and again, this should be no new information for you, right? This should be easy to do because we're back in Algebra 1, really. First thing we're going to do is move anything that does not have an x. So let's add 9 to both sides. 4x equals 24. Then we'll divide by 4. X equals 6. So if we substitute 6 back into this equation, 4 times 6 is 24. 24 minus 9 is 15. Should always work out. We should be able to substitute our answer back into the original equation for x. But two-step equations. Sometimes then the next step up was when we had variables on both sides. Negative 2x minus 13 equals 8x plus 7. So we got a variable on both sides. Now we can move all the x's to the left or we can move all the x's to the right. It doesn't really matter. We should get the same answer. In this case, since this one's a negative, I'm going to go ahead and move it to the right just to make it a positive one. And this we're going to move to the left because it's no variable. The 7 does not have a variable, so we'll move it. So we're doing them at the same time. These cancel out, and this is negative 20. 8x plus 2x is 10x, and these cancel out. So negative 20 equals 10x divided by 10. X equals negative 2. All right, and we can substitute the negative 2 back in there, and it should be a true statement if we have not made any mistakes. Take it one step farther. Again, thinking of our order of operations, just so we don't get those mixed up in there. Negative 3x minus 2 equals negative 4x plus 1 minus 4. So there's a lot going on with that. But the very first thing we need to do is the parentheses. We got a P there. So what's going on here? This negative out by itself is actually a negative 1. So we're going to multiply negative 1 times everything in parentheses. Negative 3x. Negative 1 times negative 2 is a positive 2. We have a negative 4 outside these parentheses, so we need to multiply it times everything inside. So we've got a negative 4x, and negative 4 times 1 is minus 4. And then we still have this other minus 4 that's outside the parentheses. So in that case, we need to simplify. This is as simple as it gets, negative 3x plus 2. We can't do anything with that. But over here, we got minus 4 minus 4. So we can simplify that to be minus 8. Now we're back to this problem, right? We've got variables on both sides. So let's move the 4x. Oh, we'll go left this time with the variables and move anything that's not a variable to the right side. So we're moving the 2 this way. We're moving the 4x this way. Negative 3x plus 4x is just x. Those canceled out. Those canceled out. Negative 8 minus 2 more. X equals negative 10. All right. One last thing from lesson 1, review of algebra. Area equals side squared, right? That's how you find the area of a square. Area equals side squared. If I want to rearrange that for S equals, how would I do that? How would I get what S equals from that formula, rearranging that? Little tougher one. I'll push you a little bit here. Have I stumped you? Oh, here we go. Take the square root of both sides. Cody's got that. So since this is S squared, we got to take the square root. The square root of S times S is just S. So S equals the square root of the area. Very good. So yeah, if your variable is squared, you need to take the square root of both sides, and that will get you back to a simplified just an S. So, all right, that is primarily lesson 1, which is an algebra review. Let's get into lesson 2, which is functions. This will take a little longer. We're going to talk more about functions. Anyone remember what a function is? What is a function? If we say an equation is a function, that says something very specific about it. What is a function? I'll get you started. Each x has what? Each x, if it's a function, has only what? One value. One y value. right? Every x has only one y value if we have a function. All right. So x coordinates are the inputs. And if you input an x, you're only going to get one y value out of the function. If you end up with more than one y value for an x that you input in there, it is not a function. It's still an equation. You can still get a solutions for it. You'll just have more than one solution on that. So the y's are the range, the x's are the domain on that. And if we have a graph, that's easy to determine, right? If we have a graph, if we can look at this graph right here. If we make a vertical line straight up and down, anywhere along there, it only touches the line once. That's a function. But if we have one of these situations where we got a graph that does one of those numbers, right here, it touches the graph more than once. In fact, it touches it 3 times. So that would not be a function because this x right here has more than one y value. It has 3 y values for that x. So we know this would not be a function. So it's very easy to tell if you have a graph because it's called the vertical line test. We love it when we have the graph because we can just do the vertical line test and make that very simple. So, all right, let's talk about function notation. We can have y equals 2x minus 1, and that's a function. But under function notation, we substitute the y to be f of x equals 2x minus 1. Okay, f of x and y are interchangeable. This is just called function notation, where this is our standard form that we're used to seeing on that. So, function notation, we can do a lot with that. Because a lot of things we do with functions is different operations. Is we do like, let's see this. Let's have a g of x also. This is a separate function. And it equals x plus 5. So when we have this, we can do f of x plus g of x. F of x plus g of x. And in that case, we just add 2x minus 1 plus x plus 5, right? We're just taking those, adding those together. We're taking f of x and adding g of x to it. So in this case, we just combine like terms. So it equals 2x plus x is 3x minus 1 plus 5 is plus 4. So that is what f of x plus g of x equals. We can do f of x minus g of x, right? We can do all of the arithmetic operations on it. So that we have 2x minus 1 minus x plus 5. So in this case, we got to distribute the minus. So this becomes 2x minus 1 minus x minus 5. So f of x minus g of x becomes 2x minus x is x minus 1 minus 5, x minus 6. And we can multiply and we can divide. If we divide, it ends up just being 2 of x minus 1 minus divided by x plus 5. If we multiply them there, then we end up with a quadratic equation because we'd have 2x minus 1 times x plus 5. We would distribute parentheses and do all of that. But I want to talk about one other thing on functions is inverse functions. Inverse functions. So with an inverse function, here's the notation for it, right? This is the inverse function of f of x. So if f of x is 2x minus 1, let's do this. F of x is 2x minus 1. What is the inverse of that? Well, here's the steps you do. So number 1, substitute f of x with y. Okay. So the first thing we'll do is make this y equals 2x minus 1. That's the first thing we do. Then the next thing is switch X and Y. We're going to switch the X and the Y. So this becomes X equals 2Y minus 1. All right. And then step number 3, solve for Y. So if we solve this for Y, we got to get the Y by itself. So we're going to add 1. So this becomes X plus 1 equals 2Y. We want just Y, so we're going to divide by 2. So it becomes Y. Well, let's go ahead and write the Y equals like that. We can switch sides. X plus 1 divided by 2. X plus 1 divided by 2 equals Y, or Y equals X plus 1. And then the fourth step is to replace Y with the function notation, the inverse. So this is the inverse of f of x is x plus 1 divided by 2. So in this case, this is our function. This is our inverse function. If we graph those, it's going to be a reflection over of the line y equals x. So that diagonal line y equals x. These two will be a reflection over that line when you graph it. And let me show you that. Let's physically do that here. All right, first let's put in that line y equals x. Right, so there's the line y equals x. Here is the original function, 2x minus 1. Okay, so we see it makes a line right there. So we expect this one to kind of be the same distance away on the other side of the red line. So it's going to run over here somewhere, and it's going to cross at the same point. So y equals x plus 1 divided by 2. There it is. It's a reflection of the red line. So the blue line is the original function. The inverse is the green one. And it's a perfect reflection of the y equals x. All right. Now, the other thing I want to talk about is compositions of functions. Compositions of functions. So let's get another sheet of paper to talk about compositions of functions. So for compositions of functions, that's where we have, you have an f of x, you have a g of x, and a composition is where we take f of g of x. That's where we take one function and we're putting inside the other one. You may also see this f, and there'd be like a hollow circle, f of g of x. Also, we'll see it written that way. So you may see it either way, but they mean the same thing. So let's define f of x. So in this case, it'll be x squared minus 4x minus 7. Now let's define g of x as x minus 3. Okay. If we're going to solve for f of x, f of g of x, sorry, this for f of g of x, f of g of x. That means we're going to take g of x and we're going to substitute it in for the x. See, because instead of the x inside the parentheses, we got g of x in the parentheses. So we're going to take this right here. So it's going to equal the x is going to be g of x. X minus 3 squared minus 4 times x minus 3 minus 7. We've simply taken the x, everywhere there's an x in f of x, and we've substituted g of x into that equation. All right, x minus 3 squared minus 4 times x minus 3, and then minus 7. Now we have to simplify this. So we have to square x minus 3. You know, if you square something, x minus 3 times x minus 3, you've got to take the x times the x and the x times the negative 3. And then the negative 3 times the x and the negative 3 times the negative 3. Remember, we got to multiply x times everything that's in parentheses and then negative 3 times everything that's in parentheses. So that will give us x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is plus 9. Then we got to distribute this negative 4 into the parentheses. So you get negative 4x plus 12. And then we have the minus 7 at the end. It just comes down. So that's gotten rid of the parentheses, right? Order of operations, parentheses first. This parentheses involved an exponent to get rid of. So now we need to simplify all this. So f of g of x. There's only one x squared. How many x's do we have? Let's see. We got negative 3x, and negative 4x. So those all go together. They're all negative. So we just add them together. Negative 3 plus another negative 3 is negative 6. Plus a negative 4 is negative 10x. And then our constants. We got 9 plus 12, which is 21, minus 7. So this is what f of g of x equals. F of g of x. You can also go the other way around. We could have said g of f of x. In that case, we just take f of x and substitute in for here. So that would be, the x would be this, x squared minus 4x minus 7 minus 3. Well, all we have to simplify is just combining those. So that equals x squared minus 4x minus 10. So that is g of f of x. So they don't end up the same thing. When you do f of g of x, you get this. When you do g of f of x, you get this. It's a lot simpler just to substitute for one x as opposed to an x squared and a minus x there. Let's see, the last thing I'm going to show you on that. What does it mean if we, let's see, I'm going to keep the same f of x and g of x. Now let's find f of g of 2. F of g of 2. Well, that's 2 steps involved in there. First off, let's find what g of 2 is, because now we've got an actual defined value. So g of 2 just means instead of g of x, we're substituting a 2 wherever there's an x. So g of 2 is 2 minus 3. And 2 minus 3 is negative 1. So g of 2 is negative 1. So that means we just need to find f of negative 1, because that's what g of 2 equals. So we just take f of x, and instead of x, we put in a negative 1. So that equals negative 1 squared minus 4 times negative 1 minus 7. So f of negative 1 equals negative 1 times negative 1 is a positive 1. Negative 4 times negative 1 is a positive 4 minus 7. So 1 plus 4 is 5 minus 7, negative 2. So f of g of 2 equals negative 2. Anytime you got a number in there, it's just saying substitute that number in for x and then solve. So we could actually come up, instead of ending up with equations, we end up with actual answers here. Now we should also get that same answer if we substitute 2 in here for x, because that's f of g of x. So it'd be 4 plus 14 is 18, and then substituting 2 there to be negative 20. So 4 minus 20 plus 14 is also -2. So that all works. All right, that is your big summary of those 2 lessons. You do need to go through and read those lessons. There's more in there what I gave you. There's more examples in those lessons for you to try to make sure you understand. And then you have 2 assignments, one after each lesson. So you have an assignment after lesson 101, and there's an assignment after 102, algebra review, revisiting functions. So if you have any questions, if you guys get confused on any of that, I'll be in class Wednesday. So this is a B-day week, so we don't have class on Friday, but I'll be in class on Wednesday, or you can email me if you have questions, get confused on any of that too. So otherwise, we'll only have class once a week from this point on. Next week is Labor Day, so we'll meet on Wednesday briefly, but otherwise, I won't see you until then unless you need some help with anything. So, all right, guys, go enjoy your day.
Let's get out of here. Word to your multiples. Math, baby. We're learning math, baby.